day, everyone. So, my name is Dilibangko Dayan, and my topic that I'm going to tackle today is all about logic. So, at the end of the lesson that we're going to tackle about today is in logic in math. The students are expected to understand the basic principles of mathematical logic, comprehend the notation and symbols used in mathematical logic, identify and analyze different types of logical statements such as propositions, predicates, and quantifiers. Apply logical operators such as conjunction, disconjunction, implication, and negation to construct compound statements. And lastly, to evaluate the truth value of logical statements and compound statements using truth values. So, the skills in mathematical logic will help students in various areas of mathematics, such as algebra, calculus, discrete mathematics, and proofs, as well as in developing critical thinking and problem solving abilities. So, now, what is logic? So, logic in a systematic study of valid rules of inference, the relations that lead to the acceptance of one proposition or conclusion, and the basic of a set of other proposition premises. So, it is a study of validity of statements. So it can be have a propositions which we will going to tackle this later if it is a true or false statements. So that is about the logic that we're going to tackle later. So here, proposition. So a collection of declarative statements that has either a truth value or true, or in a logic is 1, or a truth value or false, or in a logic is 0. So it consists of propositional variables denoted by letters like P, Q, S, etc., and connectives like or and not, etc. So the important topic of logic is proposition, because proposition is a declarative, right? So take note the word declarative. So in this position, it can be a true or false, and so if it is true, or in a logic is 1, and if it is a false, and in a logic is 0. So in a proposition, they have variables. So as you can see that they have letter P, Q, S, and etc. They have more. So here the example, the P 2 is an even number. So and the Q 12 plus 5 equals 16. Or the area of the circle is pi r squared. And the S is 0 is a natural number. T is A is less than 2. And U, x plus 2 equals to x. V, how far is it to the town? So we can choose this PQRSTUV if it is true or false in written there. So here in P, so as you can see that there are two is an even number, so it is a true or false. So as you can see that 2 is an even number, right? So it is a true. So in Q, 12 plus 5 equals 16 equals 16. So as you can see that 12 plus 5 equals 17, right? So that is false. And R, the area of the circle is pi r squared. So it is true. And here in S, letter S, the 0 is a natural number. 0 is a natural number class? It is false. So in T, A is less than 2. So if you don't in TUV, if we don't have right example or right answer for this, because this is not a number that you cannot solve it or can correct, or it's either we cannot decide it if it is true or false. So let's proceed. So in a truth table is it is a mathematical table used in logic which sets out the function values of logical expressions and each of their functional arguments, that is, for each combination of values taken by their logical values. So next is here we have a values that, or yeah, logical values that we're going to combine the the proposition P, Q, and S. So in connectives, in proposition logic, generally we use 5 connectives: or, and, negation, or not, implication if they're biconditional, F and only F. So first, or. So as you can see that the sign of or here is like this, the V, this or what we call this disjunction. So the or operation of two propositions A and B will, or A or B is true if at least any of the proposition variable. So here, as we connect this, or as we combine the and we're going to make a truth table. So as you can see that this is the form, or this is the face of a truth table, where we can combine the A or B. So first, in a proposition is that we're put the letter, if it is true, then, or in a logical is 1, and if it is false, in a logical is 0. So here in our first table, as you can see that it is a true, or in a logical is 1. So automatically the A or B connected is the true, and then the second table, as you can see here, that the true and the false. So if true is, if in a logical is 1, then automatically the A or B combination is true. And then here F in a logical 0 and T in a logical 1. So as you can see that the result also is true. And lastly, the F logical 0, and next is the F false or logical 0 is automatically the answer is false, or in a logical 0. So here in a 3, or in a 4 variables, or in 8 propositions, which is the A, B, or the A or B. And then as you can see it here, that if 2 squared is equals to 4, then this is the 2 is the proposition, and the squared is the Q. So here, so if 2 cubes is equals to 8, then divided by 2 is equals 4, right? So we'll make it in a truth table. So 4 truth or in a logic is 1, then 4 false in a logic of 0. So in a truth table, so if it is, oh, you will put if 4 and then 4 truth and 4 false. So in a, and also in another way or another example is if it is 2 squared is equals to 4, then divided by 2 is equals to, right? Then if it is 2, then put another 2 here, 2 true and 2 false. So here the result. So this is the result. So next is, and the conjunction, the and operation of the two propositions A and B, written A like that, and then is true if both of the proposition variable A and B is true. So put in a proposition variables, put true if it is the same A and B. So here, as you can see, the truth will, as we go to the truth table, then as you can see that if it is true, we'll put on the 2 2 squared, so the answer is 4, and then divided by 2, so we'll put it in a truth table, 2 true and 2 false. So it is, and that is in letter A. So in letter B, 2 divided by 1, so it is equals to 1. So in letter B, so put it in first table is true, then next is false, next is true, and next is false. So as in a last part, A in a combination, so remember that the propositional variables that we're going to, if it is A and B is true. So here, as you can see in the table 1, the A and B, as you can see, is that the same. So in a combination, we will put letter T, or true value, and or in a logical is 1. So next is the first table is T, or true, and the propositional B is false, so that is automatically false. And in table 3 is false and T, so it is automatically also a F, or false. And in table 4, as you can see that F and F, so automatically it is F, because as we as I said a while ago, that the combination of propositional variables is the same with the letter A and B. So next is the not, or negation. So the negation of a proposition A, written as A or like that, so is the false when A is true, and is true when A is false. So here, as you can see, the truth table. Oh, here. And then in table A is T, or in a logical 1. Also in table 2 is F. So as the result, that is the negation, or the proposition. And F and only F is by conditional logical connective, which is true when P and Q are same, E both are false or both are true. So here, if A and B or the it is the same, it is automatically true. So as you can see in the first and second in the first table, it is true, so it is automatically E true. The result is, or in a connective is true. So in table 2 is true and then false, so it is automatically false. Why? Because it is not the same. So next is F or false and 2 true, so it is automatically also a false in a connection because it is not the same also. So in the fourth table is false and then a B is false, so it is automatically a true because we are finding or they are both false. So that would be all. Thank you.